Picture this: you're standing on the surface of an alien world, the ground beneath your feet cracked and barren, the sky above a swirling mix of colors you've never seen before. The air is thin, the temperature is extreme, and you realize you're completely alone. No spaceship, no rescue team, just you and the vast, unforgiving expanse of space. How long could you survive here? What would it take to make it through even a single day on a planet that wasn't designed for life as we know it? Today, we're diving into one of the most fascinating questions in space exploration. How long could a human survive on each planet in our solar system? From the scorching heat of Mercury to the icy depths of Pluto, we'll explore the challenges, the dangers, and the incredible possibilities of surviving in the most extreme environments imaginable. Strap in, because this journey is going to take us to the very edge of what's possible and maybe even beyond. By the end of this video, you'll not only know how long you'd last on each planet, but you'll also gain a deeper understanding of just how unique and precious our home, Earth, truly is. Ready to find out if you've got what it takes to survive in the cosmos? Let's begin. Now turning to Mercury, the closest planet to the Sun, we find ourselves in a world of extremes. Imagine stepping onto a surface where temperatures can soar to a blistering 800 degrees Fahrenheit during the day, hot enough to melt lead. At night, the temperature plummets to a bone-chilling minus 290 degrees Fahrenheit. This dramatic swing is due to Mercury's lack of a substantial atmosphere, which means there's nothing to trap or distribute heat. Without an atmosphere, you'd also have no breathable air, making it impossible to survive without a spacesuit. Even with one, the intense solar radiation and relentless heat would make it a race against time. Within seconds, the lack of oxygen would render you unconscious, and within minutes, the extreme conditions would prove fatal. Mercury's surface is a barren, cratered landscape, scarred by billions of years of meteor impacts, offering no shelter or resources to sustain life. It's a stark reminder of just how hostile some corners of our solar system can be. Now, as we delve deeper into the challenges of Mercury, the lack of water becomes a glaring obstacle. Unlike Earth, Mercury has no liquid water on its surface, and its thin atmosphere offers no protection against the sun's relentless radiation. This radiation isn't just a minor inconvenience, it's a constant barrage that would damage equipment and harm any living organism over time. Adding to the difficulty is Mercury's slow rotation. A single day on Mercury lasts about 59 Earth days, meaning you'd face weeks of scorching heat followed by weeks of freezing cold. Surviving here would require more than just a spacesuit. It would demand innovative solutions. One possibility is using highly reflective materials to deflect the sun's intense heat, creating temporary shelters that could shield you from the worst of the temperature extremes. Another intriguing idea involves the planet's polar craters, where scientists believe small deposits of ice might exist. These icy pockets, hidden in permanently shadowed regions, could potentially be mined for water, offering a lifeline in this otherwise barren environment. However, even with these strategies, the challenges of Mercury's harsh conditions would make survival a precarious endeavor, reminding us just how unforgiving the solar system can be. Now turning to Venus, often referred to as Earth's twin due to its similar size, but don't let that fool you. This planet is anything but hospitable. Venus is a toxic greenhouse wrapped in a thick atmosphere composed almost entirely of carbon dioxide, with clouds of sulfuric acid swirling above its surface. The atmospheric pressure here is crushing, about 92 times that of Earth's, equivalent to being nearly 1 kilometer underwater. And if that weren't enough, the surface temperatures soar to a staggering 465 degrees Celsius, hot enough to melt lead. Stepping onto Venus would be a death sentence within seconds, as the combination of extreme heat, suffocating pressure, and corrosive atmosphere would overwhelm any human or machine. The landscape is equally unforgiving, dominated by vast volcanic plains and towering mountains, some of which are still active. Imagine a world where the ground beneath your feet could erupt at any moment, surrounded by skies that rain acid. It's a place where survival isn't just difficult, it's outright impossible without advanced, futuristic technology. Venus serves as a stark reminder of how delicate the balance of life on Earth truly is, and how hostile the rest of our solar system can be. Now shifting our gaze upward, let's explore a fascinating concept that could make Venus a potential candidate for human survival floating habitats. While the surface of Venus is a hellish nightmare, its upper atmosphere tells a different story. About 50 kilometers above the surface, the conditions become surprisingly Earth-like. Temperatures here range between 20 and 30 degrees Celsius, and the atmospheric pressure drops to levels comparable to Earth. This region, often referred to as the Goldilocks zone of Venus, has sparked the idea of creating floating cities that could hover in this relatively hospitable layer. These habitats would essentially be massive, helium-filled airships designed to drift effortlessly in the planet's thick atmosphere. The concept is not just science fiction. Scientists and engineers have proposed designs that could harness the carbon dioxide-rich air to generate breathable oxygen and even produce fuel. However, the challenges are immense. The sulfuric acid clouds that blanket Venus would pose a constant threat, corroding materials and requiring advanced protective coatings. Resource scarcity is another hurdle, as everything needed for survival, water, food, and building materials would have to be either imported or extracted from the atmosphere itself. Despite these obstacles, the idea of floating habitats on Venus represents a bold vision of human ingenuity, pushing the boundaries of what we believe is possible. It's a reminder that even in the most hostile environments, there may still be a glimmer of hope for survival, if we're willing to innovate and adapt. As we move forward, let's turn our attention to Earth, the one planet in our solar system where life thrives effortlessly, and see how it contrasts with the extreme conditions we've explored so far. Now turning to Earth, our home and the only planet in the solar system where life as we know it thrives effortlessly. Unlike the extreme and hostile environments we've explored so far, Earth is a haven of stability and abundance. Its atmosphere, rich in nitrogen and oxygen, provides the perfect balance for breathing and protecting us from harmful solar radiation. The presence of liquid water, covering more than 70% of the planet's surface, is another cornerstone of life, enabling everything from hydration to agriculture. Earth's temperature, regulated by its ideal distance from the Sun and its greenhouse effect, maintains a comfortable range that supports diverse ecosystems. These factors, air, water, and temperature, work in harmony to create a self-sustaining environment where humans can survive indefinitely without the need for advanced technology or artificial habitats. When we compare Earth to the other planets, its uniqueness becomes even more striking. On Mercury, the lack of atmosphere and extreme heat make survival impossible. Venus, with its toxic clouds and crushing pressure, is equally inhospitable. Mars, though promising, requires extensive technological intervention to support life. And the gas giants and icy worlds beyond offer no solid ground or breathable air. Earth, in contrast, provides everything we need naturally, a reminder of how rare and precious our planet truly is. As we continue our journey through the solar system, let's keep this perspective in mind. Earth isn't just our lifeline. It's a testament to the delicate balance that makes life possible. Next, we'll venture to Mars, the red frontier, to explore the challenges and possibilities of survival on a planet that, while harsh, holds the most promise for human colonization. As we set our sights on the next destination, Mars emerges as the most Earth-like planet in our solar system, offering a glimmer of hope for human survival beyond our home planet. Known as the Red Frontier, Mars presents a unique blend of challenges and opportunities. Its thin atmosphere, composed mostly of carbon dioxide, is a far cry from the breathable air we enjoy on Earth. The lack of oxygen means that without advanced technology, stepping onto the Martian surface would be fatal within minutes. Add to that the planet's extreme cold, with average temperatures hovering around -80 degrees Fahrenheit, and the absence of liquid water, and you have a world that demands ingenuity and resilience to conquer. Surviving on Mars would hinge on cutting-edge technology. Pressurized habitats would be essential to create a livable environment, shielding humans from the harsh conditions outside. These habitats would need to mimic Earth's atmosphere, providing oxygen and maintaining stable temperatures. Oxygen generators capable of converting carbon dioxide into breathable air would be a lifeline for any Martian colony. Water, another critical resource, could potentially be extracted from the planet's polar ice caps or underground reserves, though this would require sophisticated equipment and energy sources. Despite these challenges, Mars holds immense promise. Its day-night cycle is remarkably similar to Earth's, with a day lasting just over 24 hours. The planet's geology, marked by vast canyons and towering volcanoes, offers opportunities for scientific exploration and resource utilization. And while the thin atmosphere provides little protection from radiation, future colonists could seek refuge in underground shelters or use advanced materials to shield their habitats. Mars represents a bold step forward in humanity's quest to explore and inhabit new worlds. It's a place where innovation and determination could pave the way for a sustainable future, even in the face of daunting odds. As we continue our journey through the solar system, Mars stands as a testament to the resilience of the human spirit and our unyielding drive to push the boundaries of what's possible. Next, we'll delve deeper into the challenges of colonizing Mars and the groundbreaking efforts underway to make this dream a reality. As we venture deeper into the challenges of Mars colonization, the harsh realities of this alien world come into sharper focus. One of the most pressing threats is radiation. Unlike Earth, Mars lacks a robust magnetic field and thick atmosphere to shield its surface from harmful cosmic rays and solar radiation. Prolonged exposure could lead to serious health risks, including increased chances of cancer and damage to the nervous system. To combat this, future colonists might rely on underground habitats or advanced shielding materials to minimize their exposure, but these solutions come with their own set of engineering and logistical hurdles. Another formidable challenge is the planet's relentless dust storms. These storms can engulf the entire planet, lasting for weeks or even months, and pose a significant risk to equipment and infrastructure. Solar panels, a potential energy source for Martian colonies, could be rendered ineffective as dust accumulates on their surfaces. Additionally, the fine, abrasive dust could infiltrate machinery and habitats, causing wear and tear that would require constant maintenance. Engineers are already exploring ways to design dust-resistant technology, but the unpredictable nature of these storms remains a daunting obstacle. Beyond the physical dangers, the psychological toll of isolation on Mars cannot be underestimated. Imagine being millions of miles away from Earth, surrounded by a barren, lifeless landscape with limited communication and the knowledge that rescue is not an option. The mental strain of such isolation could lead to feelings of loneliness, depression, and even conflict among crew members. Addressing these psychological challenges will require careful selection of colonists, robust support systems, and perhaps even virtual reality technologies to simulate Earth-like environments and maintain morale. Despite these challenges, humanity is not backing down. Organizations like SpaceX are at the forefront of efforts to make Mars habitable. Elon Musk's vision includes developing reusable spacecraft capable of transporting humans and cargo to the Red Planet, as well as establishing a self-sustaining colony. NASA and other space agencies are also conducting extensive research, from testing life support systems to studying the effects of long-term space travel on the human body. These efforts are paving the way for a future where Mars could become a second home for humanity. As we look ahead, the dream of colonizing Mars is no longer confined to science fiction. It's a tangible goal driven by innovation, collaboration, and an unyielding spirit of exploration. While the road ahead is fraught with challenges, each obstacle overcome brings us one step closer to turning this dream into reality. Next, we'll journey beyond Mars to explore the gas giants and their moons, where even more extraordinary possibilities await. Now turning to the largest planet in our solar system, Jupiter presents a stark contrast to the rocky worlds we've explored so far. This gas giant, with its swirling bands of clouds and iconic Great Red Spot, is a mesmerizing sight, but it's also one of the most hostile environments imaginable for human survival. Unlike Earth or even Mars, Jupiter doesn't have a solid surface to stand on. Instead, its atmosphere transitions gradually into increasingly dense layers of gas, eventually reaching pressures so extreme they would crush anything in their path. The atmosphere itself is a toxic mix of hydrogen and helium, with traces of methane, ammonia, and other harmful compounds. Breathing here is out of the question, as there's no oxygen to sustain life. Even if you could somehow survive the lack of breathable air, the crushing pressure and freezing temperatures, which can drop to hundreds of degrees below zero, would make survival impossible within seconds. And that's just the beginning of the challenges. Jupiter is also surrounded by intense radiation belts, far more powerful than anything found on Earth or Mars. These belts are filled with high-energy particles that would bombard any spacecraft or human with lethal doses of radiation. Even the most advanced shielding technology would struggle to protect against this relentless onslaught. The radiation is so intense that it could damage electronics and pose a serious risk to human health, making long-term exposure unthinkable. One of Jupiter's most famous features, the Great Red Spot, is a massive storm that has been raging for centuries. This storm is so large that it could swallow Earth whole, with winds reaching speeds of up to 400 miles per hour. While it's a breathtaking sight, it's also a reminder of the planet's violent and chaotic nature. Surviving on Jupiter isn't just difficult, it's impossible. But while Jupiter itself is uninhabitable, its moons offer a glimmer of hope. With over 70 moons orbiting this gas giant, some, like Europa and Ganymede, have captured the attention of scientists as potential candidates for future exploration. These icy worlds might hold secrets beneath their surfaces, including vast oceans that could harbor life. As we continue our journey through the solar system, we'll take a closer look at these intriguing moons and the possibilities they hold. As we shift our gaze from the inhospitable giant itself, let's explore the intriguing possibilities that lie within Jupiter's moons. Among the dozens of moons orbiting this colossal planet, Europa and Ganymede stand out as potential havens for future exploration and perhaps even survival. These icy worlds, hidden beneath their frozen exteriors, might hold secrets that could change our understanding of life beyond Earth. Europa, with its smooth, icy surface crisscrossed by reddish-brown cracks, has long fascinated scientists. Beneath its frozen shell, there's strong evidence of a vast subsurface ocean, possibly containing more than twice the volume of all Earth's oceans combined. This hidden ocean is kept liquid by the gravitational forces exerted by Jupiter, which create tidal heating within Europa's core. The presence of liquid water, a key ingredient for life as we know it, makes Europa one of the most promising candidates for extraterrestrial life in our solar system. However, surviving on Europa would come with its own set of challenges. The surface temperatures hover around -260 degrees Fahrenheit, making it one of the coldest places in the solar system. Any human presence would require advanced thermal protection and energy sources to combat the extreme cold. Additionally, Europa's surface is bombarded by intense radiation from Jupiter's magnetic field, which would necessitate robust shielding for both equipment and human explorers. Ganymede, the largest moon in the solar system, presents another fascinating possibility. Unlike Europa, Ganymede has its own magnetic field, which offers some protection against Jupiter's radiation. Beneath its icy crust, scientists believe there's a salty ocean, possibly layered between multiple ice sheets. This ocean could be dozens of miles deep, creating a unique environment that might support microbial life. However, the challenges of surviving on Ganymede are no less daunting. The surface is a mix of ancient, cratered terrain and smoother, younger regions, suggesting a complex geological history. Temperatures here are similarly frigid, and while the magnetic field provides some shielding, radiation levels are still a concern. Any mission to Ganymede would need to address these issues while also navigating the moon's rugged and icy landscape. Both Europa and Ganymede offer tantalizing glimpses into the potential for life beyond Earth, but they also highlight the immense challenges of surviving in such extreme environments. From the need for advanced radiation shielding to the development of technology capable of withstanding extreme cold, these moons push the boundaries of human ingenuity. As we continue to explore the outer reaches of our solar system, these icy worlds remind us that while the challenges are great, so too are the possibilities. Next, we'll turn our attention to Saturn, the ringed planet, and its own unique set of moons that might hold the key to survival in the far reaches of space. Now turning to Saturn, the crown jewel of our solar system, we find a world that is as breathtaking as it is inhospitable. Known for its iconic rings, Saturn is a gas giant, meaning it lacks a solid surface entirely. Instead, its atmosphere is a swirling mix of hydrogen and helium, with winds reaching speeds of up to 1,100 miles per hour. These extreme conditions make survival on Saturn itself impossible. The planet's freezing temperatures, averaging around -280 degrees Fahrenheit, would instantly freeze any human or equipment. Even if you could somehow withstand the cold, the crushing atmospheric pressure would make it impossible to breathe or move. Saturn's rings, composed of ice, rock, and dust, are one of the most stunning features in our solar system. Spanning hundreds of thousands of miles, they create a mesmerizing spectacle that has captivated astronomers for centuries. But these rings are not just beautiful, they're also a reminder of the planet's volatile nature. The particles within the rings are constantly colliding, creating a dynamic and ever-changing environment. Adding to Saturn's mystique is the unique hexagonal storm at its north pole. This six-sided jet stream, first observed by the Voyager spacecraft, is unlike anything else in the solar system. Scientists believe it's caused by the planet's rapid rotation and complex atmospheric dynamics. While this storm is a marvel to study, it also underscores the extreme and unpredictable nature of Saturn's environment. Surviving on Saturn is out of the question, but its moons offer a glimmer of hope. As we move forward, we'll explore Triton, Saturn's largest moon, and the intriguing possibilities it holds for future exploration and survival. Now shifting our gaze to Triton, Saturn's largest moon, we find a world that stands out as one of the most intriguing destinations in our solar system. Unlike Saturn itself, Triton boasts a thick atmosphere primarily composed of nitrogen, making it the only moon in our solar system with a substantial atmosphere. This dense layer of gases creates a surface pressure about 1.5 times that of Earth's, offering a unique environment that could potentially support future exploration. One of Triton's most fascinating features is its liquid methane lakes and rivers. These bodies of liquid scattered across the moon's surface are the result of Triton's extremely cold temperatures, averaging around -290 degrees Fahrenheit. While these lakes are not water, they open up the possibility of using methane as a resource for energy or even as a fuel source for future missions. Imagine a future where spacecraft could refuel directly on Triton, using the moon's natural resources to extend their reach into the outer solar system. However, surviving on Titan comes with its own set of challenges. The extreme cold would require advanced thermal protection for both humans and equipment. Additionally, Titan's atmosphere lacks breathable oxygen, meaning any habitat would need to be completely sealed and equipped with oxygen generation systems. The thick haze of hydrocarbons in the atmosphere also blocks most sunlight, making solar power an unreliable energy source. Instead, future explorers might rely on nuclear power or other innovative solutions to sustain their presence. Despite these hurdles, Titan remains a tantalizing target for future missions. Its unique combination of a thick atmosphere, liquid resources, and geological activity makes it a prime candidate for studying probiotic chemistry, the chemical processes that could lead to life. Scientists believe that Titan's environment might resemble early Earth, offering clues about how life could emerge in extreme conditions. As we look ahead, Titan represents not just a challenge but an opportunity, a chance to push the boundaries of human ingenuity and explore a world that could teach us more about our own origins. With its mix of promise and peril, Titan stands as a beacon for the next generation of space explorers. Next, we'll venture further into the icy reaches of the solar system, where Uranus and its enigmatic moons await. Now turning to Uranus, the seventh planet from the Sun, we encounter a world that is as mysterious as it is inhospitable. Known as the ice giant, Uranus is composed primarily of ice's water, ammonia, and methane, surrounding a small rocky core. Unlike the terrestrial planets, Uranus lacks a solid surface, meaning any attempt to stand on it would be futile. Instead, you'd find yourself sinking through layers of slushy ice and gas, eventually crushed by the immense pressure deep within its atmosphere. The temperatures on Uranus are among the coldest in the solar system, plummeting to around -370 degrees Fahrenheit. This extreme cold, combined with the planet's lack of a solid surface, makes survival impossible for humans. Even if you could somehow withstand the freezing conditions, the crushing atmospheric pressure and toxic gases would pose insurmountable challenges. Uranus's atmosphere is primarily composed of hydrogen and helium, with traces of methane that give the planet its distinctive pale blue-green hue. This methane absorbs red light, reflecting the cooler tones that make Uranus appear as a serene, icy world from afar. Adding to its uniqueness, Uranus rotates on its side, with its axis tilted at an angle of about 98 degrees. This unusual orientation means that its poles experience extreme seasons, with each pole facing the Sun for about 42 years at a time before plunging into an equally long period of darkness. This bizarre rotation also contributes to Uranus's unpredictable and chaotic weather patterns, including powerful winds and massive storms. Surviving on Uranus is not just difficult, it's impossible. The combination of its icy composition, lack of a solid surface, and extreme environmental conditions make it one of the most hostile places in the solar system. Yet, despite its inhospitable nature, Uranus continues to captivate scientists and space enthusiasts alike. Its tilted axis and unique atmospheric features offer valuable insights into the formation and evolution of planets, reminding us that even the most challenging environments can teach us something profound about the universe. As we move forward, our journey takes us to the moons of Uranus, where the possibility of survival might not be entirely out of reach. These icy worlds, hidden in the shadows of their giant parent, hold secrets that could reshape our understanding of the outer solar system. As we venture further into the icy reaches of Uranus's system, our attention shifts to its moon's worlds that might hold the faint glimmer of hope for survival. Among these, Miranda and Ariel stand out as intriguing candidates. These moons, though small and distant, could harbor secrets beneath their frozen surfaces. Scientists speculate that both moons might have subsurface oceans hidden beneath layers of ice. These oceans, if they exist, could potentially provide the necessary conditions for life, or at least the resources needed for human survival. Miranda, the smallest and innermost of Uranus's major moons, is a world of extremes. Its surface is a patchwork of cliffs, canyons, and ridges, some of which are among the tallest in the solar system. These dramatic features suggest a history of intense geological activity, possibly driven by tidal forces from Uranus. If Miranda does have a subsurface ocean, it would likely be buried deep beneath its icy crust, shielded from the harsh conditions above. However, the extreme cold, with temperatures hovering around -370 degrees Fahrenheit, would make any attempt to access this ocean a monumental challenge. Ariel, on the other hand, presents a slightly more promising picture. Its surface is relatively smooth compared to Miranda's, with fewer impact craters, indicating a younger and possibly more active surface. This activity could be a sign of internal heat, which might help sustain a subsurface ocean. However, like Miranda, Ariel is subjected to the same brutal cold and radiation from Uranus's magnetosphere. The lack of a substantial atmosphere means there's no protection from cosmic rays or solar radiation, posing significant risks to any potential human explorers. The challenges of surviving on these moons are immense. The extreme cold would require advanced thermal protection, while the radiation would necessitate robust shielding or underground habitats. Accessing any subsurface oceans would require drilling through miles of ice, a feat that would demand cutting-edge technology and immense resources. Yet, the possibility of liquid water, a key ingredient for life, makes these moons tantalizing targets for future exploration. While the moons of Uranus are far from hospitable, they represent a frontier where human ingenuity might one day prevail. The potential for subsurface oceans offers a glimmer of hope, reminding us that even in the most hostile environments, the universe may still hold surprises. As we continue our journey through the solar system, these icy moons serve as a testament to the resilience of life and the boundless curiosity of humanity. Next, we turn our gaze to Neptune, the final stop in our planetary odyssey, where even greater mysteries await. Now turning to Neptune, the farthest planet from the Sun, we encounter a world of unimaginable extremes. Known as the windy giant, Neptune is a place where survival is not just difficult, it's outright impossible. This icy behemoth is shrouded in a deep blue atmosphere, a result of methane gas absorbing red light and reflecting blue. But don't let its serene color fool you. Neptune is a planet of chaos. Its winds are the fastest in the solar system, reaching speeds of up to 1,200 miles per hour, nearly supersonic. These ferocious winds whip across the planet, creating massive storms that dwarf anything we've seen on Earth. The most famous of these is the Great Dark Spot, a storm system so vast it could swallow our entire planet whole. The temperatures on Neptune are equally unforgiving, plunging to a bone-chilling -350 degrees Fahrenheit. This extreme cold, combined with the lack of a solid surface, makes the idea of standing on Neptune impossible. Unlike Earth or even Mars, Neptune is a gas giant, meaning it has no ground to stand on. Instead, its atmosphere gradually thickens as you descend, eventually turning into a slushy mix of water, ammonia, and methane ice. Even if you could somehow withstand the crushing pressures and freezing temperatures, there's nowhere to land, just an endless, turbulent sea of gas and ice. Adding to the hostility is Neptune's intense radiation environment. The planet's magnetic field, though weaker than Jupiter's, still generates powerful radiation belts that would be lethal to any unprotected human. Without advanced shielding, exposure to this radiation would be fatal within moments. And let's not forget the sheer distance from the Sun. Neptune receives only a fraction of the sunlight we enjoy on Earth, plunging it into perpetual twilight. This lack of solar energy makes it impossible to rely on solar power, further complicating any hypothetical survival scenario. In short, Neptune is a world of extremes, violent winds, freezing temperatures, crushing pressures, and lethal radiation. It's a place where even the most advanced technology would struggle to keep a human alive. But as we've seen throughout our journey, the solar system is full of surprises. While Neptune itself is uninhabitable, its largest moon, Triton, offers a glimmer of hope. As we move forward, we'll explore Triton's icy surface and the tantalizing possibilities it holds for survival in this distant corner of the solar system. Now shifting our gaze to Triton, Neptune's largest moon, we find a world that stands in stark contrast to the gas giant it orbits. While Neptune itself is a hostile, storm-ravaged planet, Triton offers a glimmer of possibility for survival, albeit under extreme conditions. This icy moon is one of the most intriguing objects in the solar system, with a surface that hints at both danger and opportunity. Triton's most striking feature is its geysers, which spew nitrogen gas and dark dust particles high into its thin atmosphere. These geysers are powered by the moon's internal heat, a remnant of its gravitational interactions with Neptune. While this activity suggests a dynamic environment, it also underscores the challenges of living on Triton. The thin atmosphere, composed mostly of nitrogen with traces of methane, offers little protection from the harsh conditions of space. Without a thick atmosphere to shield it, Triton's surface is bombarded by radiation, making long-term survival a daunting prospect. The temperatures on Triton are among the coldest in the solar system, plummeting to a frigid -390 degrees Fahrenheit. This extreme cold would make any surface activity nearly impossible without advanced thermal protection. However, the moon's icy surface could hold valuable resources. Triton's ice is thought to contain water, ammonia, and other volatile compounds which could potentially be harvested for survival. These resources might be used to create breathable air, fuel, or even building materials for habitats. One of the most fascinating aspects of Triton is its retrograde orbit, meaning it moves in the opposite direction of Neptune's rotation. This unusual orbit suggests that Triton was once a free-floating object captured by Neptune's gravity. This capture likely caused significant heating in Triton's interior, which may still contribute to its geological activity today. While this internal heat is a double-edged sword providing energy but also instability, it could be harnessed to support human habitation. Despite these possibilities, the challenges of surviving on Triton are immense. The moon's thin atmosphere offers no protection from solar and cosmic radiation, requiring advanced shielding for any potential habitats. The extreme cold would demand constant energy input to maintain livable conditions, and the lack of sunlight would make solar power impractical. Instead, any survival strategy would likely rely on nuclear energy or other advanced power sources. In the end, Triton represents both the promise and peril of survival in the outer solar system. While its resources and geological activity make it a tantalizing target for exploration, the harsh realities of its environment remind us of the immense challenges we must overcome to thrive in such distant worlds. As we continue our journey, we'll explore even more remote corners of the solar system, where the line between possibility and impossibility becomes ever more blurred. Now turning to Pluto, the distant dwarf planet at the edge of our solar system, we encounter a world that is as mysterious as it is inhospitable. Once considered the ninth planet, Pluto now holds the title of a dwarf planet, but its allure remains undiminished. This icy world, with its heart-shaped glacier and rugged terrain, presents a stark reminder of the challenges of survival in the farthest reaches of our cosmic neighborhood. Pluto's surface is a frozen expanse, with temperatures dropping to an unimaginable -387 degrees Fahrenheit. This extreme cold makes it one of the coldest places in the solar system, far too harsh for any human to endure without advanced technology. The thin atmosphere, composed mostly of nitrogen with traces of methane and carbon monoxide, offers no protection from the vacuum of space or the relentless bombardment of cosmic radiation. Without a thick atmosphere to retain heat or shield against radiation, survival on Pluto would be impossible without significant artificial support. Adding to the challenges, Pluto lacks a solid surface in the traditional sense. Its icy crust is a mix of frozen nitrogen, methane, and water ice, creating a brittle and unstable terrain. Walking on Pluto would feel like stepping onto a fragile, frozen shell that could crack or shift beneath your feet. The lack of a stable surface makes building any kind of habitat or infrastructure a monumental task, requiring materials and technology far beyond our current capabilities. One of Pluto's most iconic features is its heart-shaped glacier known as Tombaugh Regio. This massive, bright expanse of frozen nitrogen and methane is a striking visual reminder of Pluto's unique beauty. However, beneath its serene appearance lies a dynamic and ever-changing landscape. The glacier's surface is constantly shifting due to sublimation, where ice turns directly into gas, creating a thin, hazy atmosphere that occasionally snows back onto the surface. This process, while fascinating, further complicates any potential for survival, as the environment is in a constant state of flux. Despite its challenges, Pluto remains a captivating object of study. Its distance from the Sun means it receives only a fraction of the sunlight we enjoy on Earth, making solar power impractical. Any attempt to survive here would require alternative energy sources, such as nuclear power, to sustain life and operations. The extreme isolation and lack of resources also mean that any mission to Pluto would need to be entirely self-sufficient, carrying everything needed for survival from the start. In the end, Pluto serves as a stark reminder of the limits of human endurance in the cosmos. While its icy beauty and unique features make it a fascinating destination for exploration, the harsh realities of its environment make survival an insurmountable challenge. As we continue our journey through the solar system, Pluto stands as a testament to the incredible diversity and extremes of the worlds that lie beyond our own. As we venture beyond Pluto, our journey takes us into the Kuiper Belt, a vast region of icy bodies and dwarf planets that stretches far beyond the orbit of Neptune. This distant frontier, often referred to as the solar system's frozen backyard, is home to countless objects that hold secrets about the early days of our cosmic neighborhood. But could humans ever survive in this remote and frigid expanse? Let's explore the possibilities and challenges of life in the Kuiper Belt. The Kuiper Belt is a place of extremes. Temperatures here rarely rise above -370 degrees Fahrenheit, making it one of the coldest regions in the solar system. The icy bodies that populate this area, such as Eris, Haumea, and Makemake, are composed of frozen methane, nitrogen, and water, creating environments that are as harsh as they are beautiful. Surviving in such conditions would require advanced technology to generate heat and protect against the relentless cold, as well as innovative solutions to extract and utilize the limited resources available. Radiation is another significant challenge in the Kuiper Belt. Far from the protective shield of the Sun's magnetic field, this region is bombarded by cosmic rays and solar particles. Without a thick atmosphere or magnetic field to deflect this radiation, any human presence would need robust shielding to prevent long-term health risks. This could involve habitats built deep beneath the surface of these icy worlds or advanced materials designed to absorb and block harmful radiation. Isolation is perhaps the most daunting obstacle in the Kuiper Belt. The sheer distance from Earth means that communication delays could stretch to hours, making real-time contact impossible. Any mission to this region would need to be entirely self-sufficient, carrying all the necessary supplies and equipment for survival. The psychological toll of such isolation cannot be underestimated, as astronauts would face the challenge of living in a remote, uncharted wilderness with no hope of quick rescue or resupply. Despite these challenges, the Kuiper Belt offers intriguing possibilities for survival. Some of these icy bodies may harbor subsurface oceans, similar to those suspected on moons like Europa and Enceladus. If liquid water exists beneath the frozen crusts of Kuiper Belt objects, it could provide a potential resource for sustaining life. Additionally, the abundance of frozen volatiles such as methane and nitrogen could be harvested to produce fuel, breathable air, and even building materials for habitats. The Kuiper Belt also represents a treasure trove of scientific discovery. Studying these ancient remnants of the solar system's formation could provide insights into the origins of planets and the conditions that led to the emergence of life on Earth. While survival here would be a monumental challenge, the potential rewards for science and exploration make it a tantalizing destination for future missions. As we consider the possibilities of life in the Kuiper Belt, it's clear that this distant region is both a frontier of opportunity and a test of human ingenuity. The extreme cold, radiation, and isolation present formidable obstacles, but they also inspire us to push the boundaries of what's possible. Whether through robotic probes or daring human missions, the Kuiper Belt beckons as a realm of discovery, reminding us that the solar system still holds countless mysteries waiting to be unraveled. Now, as we cast our gaze beyond the boundaries of our solar system, we enter the realm of exoplanets, worlds orbiting distant stars that could one day become the next frontier for human survival. These distant planets, some of which may resemble Earth in size, composition, or even climate, hold the tantalizing promise of new homes for humanity. But reaching them, let alone surviving on them, presents challenges that push the limits of our imagination and technology. The first hurdle is the sheer distance. Even the closest exoplanet, Proxima Centauri b, lies over 4 light-years away. At our current technological capabilities, a journey to such a destination would take tens of thousands of years. Interstellar travel would require breakthroughs in propulsion systems, such as light sails or fusion drives, to reduce travel times to a more manageable scale. Without these advancements, the dream of reaching another star system remains just that, a dream. Once we arrive, the challenges of survival on an exoplanet would depend heavily on its environment. While some exoplanets may orbit within the habitable zone of their stars where temperatures could allow liquid water to exist, others might be plagued by extreme conditions. Planets tidally locked to their stars, for example, could have one side perpetually scorched by heat while the other remains frozen in eternal darkness. Others might have atmospheres thick with toxic gases or lack the magnetic fields needed to shield life from harmful radiation. The search for Earth-like exoplanets is already underway, with missions like NASA, Kepler, and TESS telescopes identifying thousands of candidates. These discoveries have revealed a stunning diversity of worlds, from rocky super-Earths to gas giants orbiting close to their stars. Yet, finding a planet that truly mirrors Earth's conditions, with a stable atmosphere, liquid water, and a suitable climate remains a daunting task. Even if such a planet exists, the logistics of transporting humans and establishing a self-sustaining colony would require innovations far beyond our current capabilities. Despite these challenges, the pursuit of exoplanets represents a bold step forward in our quest to understand the universe and our place within it. The possibility of discovering a world that could support human life fuels our curiosity and drives us to explore the cosmos with renewed determination. As we continue to peer into the depths of space, the dream of finding a new Earth reminds us that the universe is vast, full of potential, and waiting to be explored. As we reflect on the incredible journey through our solar system, it's clear that survival beyond Earth is no small feat. From the scorching inferno of Mercury to the icy desolation of Pluto, each planet and moon presents its own unique set of challenges. The lack of breathable air, extreme temperatures, and hostile environments remind us just how fragile human life is in the vastness of space. Yet, these challenges also highlight the resilience and ingenuity of humanity. Surviving on other worlds demands more than just courage. It requires cutting-edge technology, innovative solutions, and an unwavering ability to adapt. Whether it's building floating habitats in Venus's upper atmosphere, shielding ourselves from radiation on Mars or harnessing resources from distant moons, the key to survival lies in our ability to push the boundaries of what's possible. Every step forward in space exploration brings us closer to understanding how we can thrive in environments that seem utterly inhospitable. The lessons we've learned from exploring our solar system will be invaluable as we set our sights on even more distant horizons. The challenges of surviving in space are immense, but they are not insurmountable. With each discovery, each technological breakthrough, and each daring mission, we inch closer to a future where humanity can call more than just Earth home. The ultimate challenge of space survival is not just about enduring, it's about thriving, innovating, and expanding our presence among the stars. As we look to the future, one thing is certain: the journey ahead will test our limits, but it will also inspire us to reach new heights. The universe is vast and the possibilities are endless. The question is no longer whether we can survive in space, but how far we're willing to go to make it happen. As we bring our journey through the solar system to a close, it's impossible not to marvel at the sheer diversity of challenges each planet and moon presents. From the blistering heat of Mercury to the frozen expanse of Pluto, the harsh realities of space remind us just how extraordinary Earth truly is. Yet, these challenges also serve as a testament to human ingenuity and our relentless drive to explore the unknown. The future of space survival hinges on our ability to innovate and adapt. Whether it's developing advanced habitats to withstand Venus's toxic atmosphere, creating sustainable ecosystems on Mars, or tapping into the resources of distant moons, the solutions we devise today will shape the possibilities of tomorrow. Every breakthrough in technology, every daring mission, and every new discovery brings us one step closer to a future where humanity can thrive beyond the confines of our home planet. While the road ahead is fraught with obstacles, it's also filled with promise. The universe is vast and the potential for exploration is limitless. The challenges we face are not just barriers, they are opportunities to push the boundaries of what we thought was possible. As we continue to explore, innovate, and dream, we move closer to a future where the stars are not just points of light in the sky, but destinations waiting to be reached. Thank you for joining us on this incredible journey through the solar system. If you enjoyed this exploration of space survival, don't forget to like, share, and subscribe for more futuristic content. Let us know in the comments which planet or moon you'd most like to visit and what you think the future of space exploration holds. Together, let's keep reaching for the stars.